At exactly 60 kilometers above your skull, cosmic radiation violently strips electrons from atmospheric molecules, leaving behind a massive, suspended ceiling of positively charged ions. You walk outside, look up, and perceive an empty sky. You are entirely blind to the physics. You are standing at the bottom of a live, planetary scale circuit. A $12 length of copper wire can pull real electrical energy out of that empty sky. There is no solar panel. There is no battery. There is no rotating turbine. There is no grid connection. There is only a wire, a rod driven into the dirt, and the atmosphere above your head. If you paid a utility bill last month, you paid a premium for a deep, systemic confusion. You were never taught the fundamental difference between voltage and power. That difference dictates everything. The device works. The physics is absolute. You could assemble a functional version of this mechanism in your backyard this weekend. Yet, the honest narrative of what this technology can physically accomplish has been smothered beneath a century of profitable mythology. So, what exactly is atmospheric electricity? How much of this ambient field can we genuinely capture? And why does the profound gap between the physical reality and the internet promise matter so deeply? Let us dissect the mechanism. The atmosphere of this planet has been electrically charged for billions of years before a human mind existed to comprehend it. When Benjamin Franklin flew a kite into a localized thunderstorm in 1752, he was not performing a parlor trick. He was measuring a gradient. His lightning rod was never intended to be a mere symbol of scientific enlightenment. It was a brutal, practical tool. It was engineered on the concrete observation that the sky carries a lethal charge, that this charge seeks the Earth through conductive pathways, and that human architecture can dictate the route. By the 1840s, telegraph operators constructing the first long-distance electrical communication networks encountered an anomaly. Their copper lines were transmitting ghost signals. Under specific topographical geometries and highly specific meteorological conditions, Samuel Morse's telegraph lines powered themselves entirely independent of their chemical batteries. This was not folklore. This was a documented, financially frustrating engineering failure that field crews were forced to mathematically accommodate. The atmosphere was forcing charge through their infrastructure, whether human commerce desired it or not. By 1899, Nikola Tesla constructed an experimental laboratory in Colorado Springs for the singular purpose of measuring and exploiting this ambient field. His surviving logs detail massive atmospheric electrical gradients. Tesla concluded that the Earth's surface and the upper ionosphere functioned as the two opposing plates of a colossal capacitor. The breathable air between them was merely the dielectric gap. He hypothesized that precise antenna geometries could tap this reservoir. His Wardenclyffe Tower, erected on Long Island between 1901 and 1917, was financed by J.1. Morgan to serve as a global wireless transmission node. That funding was abruptly severed the moment Morgan understood that the system might broadcast energy without a mechanism for metering consumption. That fragment of the suppression mythology is historically accurate. But the underlying physics of Wardenclyffe was always focused on the efficiency of transmission. It was never about the unlimited extraction of free energy. Tesla definitively proved that the atmosphere holds genuine charge, that real voltage gradients exist, and that a precisely engineered antenna can harvest a fraction of it. The variable he left unresolved, and the variable that the digital fringe has shamelessly exploited ever since, is the exact magnitude of that harvest. Researchers at the Massachusetts Institute of Technology published peer-reviewed data in the early 2020s, verifying that specialized antenna arrays and triboelectric nanogenerators harvest atmospheric charge. The data is empirical. Sustained outputs exist strictly in the microwatt range, peaking into the low milliwatts under optimal meteorological conditions. The Internet of Things sector quietly commercialized this exact physical reality years ago. Corporations like EnOcean and PowerCast currently manufacture deployed devices that operate entirely on ambient energy, atmospheric, thermal, and radio frequency without a battery and without a grid tie. Every single one of these units powers microcontrollers, environmental sensors, and wireless transmitters. Not a single one of them powers a light bulb, a compressor, or a residential appliance. That limitation is not a failure of product design. It is a strict boundary of physics. Here is the underlying mechanism. The crust of the Earth carries a net negative charge. The ionosphere carries a net positive charge. This total vertical separation creates a planetary scale capacitor, sustaining roughly 300,000 volts of potential difference across the atmospheric gap. At ground level, in absolute fair weather, this electrical pressure translates to a measurable voltage gradient of roughly 100 to 200 volts for every vertical meter. The numbers sound staggering. A standard copper wire rising 10 meters into the sky is sampling a 1,000-volt gradient. The antenna is not pulling energy out of a vacuum. It is sitting inside a live electrical field. But voltage without current is water pressure in a sealed pipe. It is potential without flow. The atmospheric current density at ground level is roughly 1 to 3 picoamperes per square centimeter. That is 3 trillionths of a single ampere. Mathematically multiply 100 volts by that microscopic current over a square centimeter, and the yield is 1/10,000,000th of a watt. To harvest precisely 1 watt of usable power, you require a collection area approaching 10 million square centimeters. You need a football field of copper. This is precisely why Tesla's Wardenclyffe architecture had to be monolithic. He was not trying to outsmart physics. He was trying to scale the collection area. A $12 antenna pulls real charge, but the collection area is microscopic, so the power output is microscopic. As a thunderstorm approaches, charge separates massively between the cloud layer and the ground. Local field strengths violently warp, spiking by a factor of 100. Engineers monitoring their antennas see this surge instantaneously. The device works. The storm variation is undeniable, but the sustained output remains firmly chained to the milliwatt range. What fundamentally transformed this technology was not new physics. It was a revolution in silicon. A modern microcontroller operating in deep sleep mode consumes roughly 10 microwatts. A digital temperature sensor can transmit a wireless data packet on a split-second burst of a single milliwatt. A precisely engineered harvester, a 5-meter vertical copper wire, a solid copper rod driven 1.5 meters into the soil, and a highly efficient rectifier circuit generates 1 to 5 milliwatts continuously in fair weather. That is enough electrical sustenance to run a remote environmental sensor forever. A wildlife tracker, a moisture probe, or a radio beacon broadcasting its coordinates every 30 seconds. No batteries, no solar panels, no grid. The mechanism has no moving parts and makes absolutely no sound. It sits exposed to the elements, accumulating invisible charge from the air, exactly how a stone cistern slowly fills with rain. Slowly, reliably, silently. There is profound gravity in that image. A solitary copper wire tethered to nothing but the dirt below and the sky above, powering a localized digital system indefinitely for the cost of basic hardware materials. The physics is ancient. The application is now. So, why is this invisible architecture absent from the mainstream conversation about energy? The honest answer begins with the physics. Atmospheric electricity at ground level is brutally diffuse. It cannot support bulk energy consumption. That is not corporate suppression. That is the density problem, and no existing antenna geometry circumvents it. In frigid, dry environments, with zero storm activity, the output degrades further. Urban centers introduce crippling electromagnetic interference. Overhead power lines and radio transmitters drown the ambient direct current in electrical noise. This mechanism is not a household energy solution, and under currently understood physics, it never will be. The deeper answer lies in what global markets reward. The energy industry operates exclusively on the kilowatt hour. Institutional research capital inevitably follows commercializable, grid-scale deployment. A technology trickling out milliwatts simply does not attract the tidal wave of funding that solar panels secured once they mathematically scaled for utilities. Furthermore, hardware interacting with residential infrastructure requires brutal UL and IEC certifications. Micro-harvesting antennas exist in a regulatory gray zone, making consumer certification vastly more expensive than the meager revenue the final product could generate. There is no consumable filter to replace. There is no software subscription. The infrastructure that makes a contractor wealthy is the infrastructure they choose to install. The technology that makes an insurance underwriter comfortable is the category they already understand. The unlimited free energy myth was wildly more profitable than the quiet truth. Consequently, the truth was abandoned. The digital fringe inherited Tesla's complex legacy and mutated it into a deranged story about suppressed unlimited power. That mutation rendered the entire field of study scientifically radioactive. Elite engineers refused to associate their careers with internet pseudoscience. The honest iteration of the technology, modest, measurable, and highly effective for micro applications, got buried alive beneath a mountain of noise. What can actually be reclaimed is highly specific. Drive a solid copper or galvanized steel rod exactly 1.5 meters into the soil. Erect a vertical copper antenna 3 to 10 meters into the air. Feed that tiny current into a high-impedance Cockcroft-Walton multiplier circuit or a MOSFET-based rectifier, and charge a supercapacitor over hours. The amateur radio community and open-source architects on Hackaday have exhaustively documented these builds. The output numbers are mercilessly consistent. The fatal mistakes that kill the circuit are basic. Inadequate earth grounding, deploying cheap diodes with high forward voltage loss, or proximity to buildings that inadvertently act as Faraday cages. Conversely, open terrain, significant elevation, and pre-storm barometric shifts aggressively push the output upward. The atmosphere has systematically delivered electrical charge to every towering oak tree and every rusted fence post since long before the grid was conceptualized. The physics was never in dispute. What society abandoned was the patience to work within the real numbers. A near-future world, populated by billions of microsensors grazing on ambient energy, exactly the way flora grazes on sunlight, is not science fiction. It is actively deployed in remote infrastructure today. The imperative step forward is knowing what the mechanism actually is, engineering it with precision, and aggressively refusing to let a profitable myth crowd out the physical reality. If that fundamental principle surprised you, the realization that a massive physical field you unknowingly walk through every day contains harvestable energy in quantities too minuscule to sell, but too profoundly useful to ignore, then the next lecture will push the boundary further, because in 1821, a physicist named Thomas Seebeck proved that a simple temperature differential between two distinct conductive materials physically forces a voltage into existence. The aerospace industry exploits that exact principle to power deep space probes that have functioned flawlessly for half a century with zero moving parts and zero chemical battery replacements. That technology has never been integrated into your home, not because the physics fails at sea level. It is absent for the exact socio-economic reasons that history continuously returns to. Go outside. Drive a 1.5 meter galvanized steel rod into the damp earth. Hoist 10 meters of bare copper wire into the wind. Measure the invisible weight of the sky. You are still standing at the bottom of a 60-kilometer ceiling of positive ions, entirely blind to the current.